Are you sitting down right now? Good. Stay right where you are. Do not move. I want you to be perfectly still, because I have a very simple question for you. A question so simple it sounds almost insulting. Ready? How fast are you moving? And I know what you're going to say. You are going to say, I am not moving, Feynman. I am sitting in a chair. And you feel very confident about that. You can look down at your feet. They are not going anywhere. Your coffee cup is sitting on the table. It has not budged. Everything around you confirms, absolutely confirms, that you are stationary. But you are wrong. You are catastrophically, hilariously wrong. And by the time I am finished with you today, you are going to realize that right now, in this very moment, you are hurtling through space at about 1.3 million miles per hour. And the worst part, nobody can tell you exactly what you are moving toward. There is something out there pulling you, pulling me, pulling our entire galaxy, and we are still trying to figure out what it is. So let us start with something everyone agrees on. Something you learned when you were a kid, and then probably forgot because it seemed too obvious to matter. The Earth spins. You know this. It is the reason you have morning and evening and night. The planet turns on its axis once every 24 hours. Fine. But have you ever actually sat down and worked out what that means for your body right now in that chair? The Earth is roughly 25,000 miles around at the equator, and it makes that full turn in one day. So if you are standing on the equator, the ground under your feet is moving at about 1,040 miles per hour. Over 1,000. That is faster than the speed of sound. You are riding on the surface of a rock that is whipping around faster than a bullet from a high-powered rifle, and you cannot feel a thing. Now, if you live farther from the equator, up in New York or London or Tokyo, the number goes down because the circle you trace each day is smaller. At 45 degrees latitude, you are doing maybe 700 miles per hour. Up near the Arctic Circle, maybe 400. And at the poles, you are barely moving at all. You just rotate in place like a very cold, very patient ballerina. But even at the lower latitudes, we are talking about hundreds of miles per hour. That is a sports car on the Autobahn. And you are doing it right now without spilling your drink. Why do you not feel it? This is worth pausing on because the answer reveals something fundamental about physics. You do not feel speed, you feel acceleration, changes in speed, bumps and swerves and jolts. But if you are moving in a straight line at a constant velocity, the laws of physics inside your room are identical to the laws of physics in a room that is standing still. This is not a trick. It is not an approximation. It is exactly, precisely, mathematically true. Galileo figured this out 400 years ago. He imagined a ship sailing on perfectly smooth water and asked, can you do any experiment below decks that would tell you whether the ship is moving? Drop a ball, pour some water, watch a butterfly fly around the cabin. Everything behaves exactly as it would if the ship were tied to the dock. On the spinning Earth, things are slightly more complicated because we are not moving in a straight line. We are moving in a circle. And circular motion involves a constant change of direction, which is a kind of acceleration. So technically there should be effects, and there are. We call them Coriolis effects. Hurricanes spin one way in the northern hemisphere and the other way in the southern hemisphere. Long-range artillery shots drift sideways. Foucault's pendulum slowly rotates its plane of swing over the course of a day. These are real measurable consequences of the Earth's spin. But they are subtle. You have to watch carefully for a long time with precise instruments to detect them. Your body is completely oblivious. It has no idea. Here is a thought experiment I enjoy. Suppose, for the sake of argument, the Earth suddenly stopped spinning. Not gradually, instantaneously. What would happen to you? Well, the ground would stop, but you would not. You and everything not bolted to bedrock would continue moving sideways at whatever speed you had. 1,000 miles per hour at the equator. You would be flung forward like a passenger in a car that hits a brick wall. Except this crash would happen to every object on the surface simultaneously. Buildings would shear off their foundations. The oceans, still carrying all their rotational momentum, would surge out of their basins in waves miles high. The atmosphere, which had been rotating right along with the surface, would keep going as a 1,000-mile-per-hour wind that would sandblast the continents clean. It would be the end of civilization and nearly the end of life on Earth. All because of a motion you cannot currently detect with any of your senses. That is the hidden violence of the spin. It is harmless only because it is constant. The moment it changes, even slightly, you pay the price. The smoothness of your ride is not evidence that nothing is happening. It is evidence that everything is happening in perfect, unbroken agreement. So layer 1, you are spinning it up to 1,000 miles per hour, and the only evidence is a pendulum, some hurricanes, and the thought experiment I just described. Not exactly obvious. All right, let me add the next layer, and suddenly that first number is going to look almost quaint. The Earth does not just spin, it also goes around the sun. You knew that. Of course you did. But again, have you done the arithmetic? The Earth sits about 93 million miles from the sun, and it makes one full lap every year. The path it traces is enormous. When you work out the circumference of that orbit and divide by the number of hours in a year, you get approximately 67,000 miles per hour. 67,000. Your spinning motion, that impressive 1,000 miles per hour, it is less than 2% of your orbital speed. It is a rounding error. Right now, as you sit in that chair, you are screaming through space at 67,000 miles per hour, along a curved path around a nuclear furnace that is 1,000,000 times the volume of your planet. And again, you feel absolutely nothing. Let me put this in perspective. At 67,000 miles per hour, you could fly from New York to Los Angeles in about 2.5 minutes. Every single second, the Earth shifts about 18.5 miles along its orbit. In the time it takes you to read this sentence out loud, you have moved roughly 100 miles, gone, behind you. You will never be in that part of the orbit again until next year. And there is a delicious little detail here that most people miss. The Earth's spin and its orbital motion combine in a way that means you are actually moving faster through space at midnight than you are at noon. Think about it. At midnight, the side of the Earth you are on faces in the same direction as the orbital motion. The spin adds to the orbit, but at noon your side of the Earth faces backward against the direction of travel. The spin subtracts from the orbit. The difference is only about 2,000 miles per hour, which compared to 67,000 is small. But it is real. You are literally moving 2,000 miles per hour faster at midnight than you are at high noon. Nobody tells you this stuff, and I think that is a crime. There is another way to feel the reality of this orbital motion, even though you cannot sense it directly. Point a telescope at Mars and watch it over several weeks. Sometimes Mars appears to move backward against the background stars. Retrograde motion. For centuries, astronomers tied themselves in knots trying to explain this with epicycles and difference and all sorts of elaborate geometry. The real explanation is simple. The Earth is overtaking Mars on the inside track. It is like passing a slower car on the highway. For a moment, the other car seems to slide backward relative to the distant mountains, even though it is still moving forward. The retrograde motion of Mars is visible, direct proof that you are in motion. You can see its consequences with your own eyes. And yet, sitting in your chair, not a flutter, nothing. So we have layer 1, spinning at 1,000 miles per hour. Layer 2, orbiting the sun at 67,000 miles per hour. Are we done? We are not even close. But before I add the next layer, I want you to notice something about how these velocities combine. Because they do not simply add up. Your spin velocity and your orbital velocity point in different directions, and those directions keep changing. At midnight, they roughly align and you move faster. At noon, they roughly oppose and you move slower. At dawn and dusk, they are nearly perpendicular, and you have to do the geometry to find the total. This is a general rule, and it matters more with each layer we add. Every new motion has its own speed and its own direction, and the real question is never just how fast, it is how fast, in which direction. Right now, the total velocity at any instant is the sum of all these vectors, all these arrows pointing different ways, and that sum changes every moment as the Earth spins and orbits and the whole system wheels through space. You are not on a straight track. You are on a corkscrew, inside a corkscrew, inside a corkscrew. Your actual path through the universe, if you could trace it with a pen on a cosmic sheet of paper, would be an insanely complicated spiral that never quite repeats. No 2 seconds of your trajectory are identical. You are tracing a path through space that has never been traveled before and will never be traveled again. Keep that in your mind. It becomes important later, because the sun is not standing still either. This took a long time for people to truly appreciate. For most of human history, the sun was the center of things, at least once we got past the idea that the Earth was the center. Copernicus put the sun on the throne. But the sun is just another star, one among hundreds of billions in a massive spinning galaxy we call the Milky Way. And the sun, along with our entire solar system, every planet, every moon, every asteroid, every comet, is orbiting the center of that galaxy. The Milky Way is about 100,000 light-years across. A light-year, remember, is the distance light travels in 1 year, about 6 trillion miles. So the galaxy is roughly 600,000 trillion miles wide. The Sun sits about 26,000 light-years from the center. Not at the edge, not at the center, but about 2/3 of the way out, in a relatively quiet suburban arm of the spiral. And we are orbiting the galactic center at roughly 500,000 miles per hour. 500,000 miles per hour. How do we know this? We cannot exactly look out the window and see the galaxy spinning. We are inside it. Measuring the rotation of something you are inside of is like measuring the speed of a merry-go-round while you are sitting on one of the horses. Everything nearby moves with you. The only way to tell is to look at things that are not on your merry-go-round. Distant objects, fixed reference points. And that is exactly what astronomers do. They measure the Doppler shifts of stars and gas clouds at different distances from the galactic center and build up a rotation curve, a map of how fast things orbit at each distance. At our position, the speed is about 220 kilometers per second. Convert that to miles per hour, and you get roughly 500,000. Here is what makes that number hit harder. At 500,000 miles per hour, you are moving fast enough to circle the Earth in about 3 minutes. Just 3 minutes to go all the way around the planet. And that is not your top speed for the day. That is just the galactic component. Let all three numbers sit in your head at once. 1,000, 67,000, 500,000. Each layer dwarfs the one before it. The galactic orbital speed is so vast that your spin and your orbit around the Sun combined amount to about 14% of your speed around the galaxy. They are noise. At 500,000 miles per hour, the solar system covers roughly 4.5 billion miles in a single year. And yet, at this absurd velocity, it takes approximately 230 million years to complete one single orbit around the Milky Way. One trip, 230 million years. That number has a name. We call it a galactic year. And the Sun is about 4.5 billion years old, which means it has completed roughly 20 orbits in its entire lifetime. 20 laps. That is all. Think about what the Earth looked like the last time the Sun was in roughly this position. 230 million years ago, the supercontinent Pangaea was still mostly intact. The first dinosaurs were just appearing. No birds existed, no flowers, no grass, no mammals, nothing that looks like the modern world. And here we are, one orbit later, having gone all the way around, and everything has changed beyond recognition. One lap, the galaxy is that big. We are that small. And what are we orbiting? What sits at the center, holding this whole carousel together? A black hole, a supermassive one. We call it Sagittarius A star because it lies in the direction of the constellation Sagittarius. It has a mass of about 4 million suns packed into a region smaller than our solar system. If you took our sun and multiplied it by 4 million, then crushed all of that into a space about the size of Mercury's orbit, you would get a gravitational field so intense that not even light can escape its grip. Stars near the galactic center orbit this thing at thousands of miles per second, tracing out ellipses we can actually track year after year, like watching gnats circle a lamp. Gas spirals inward, heats to millions of degrees, and flashes in X-rays before disappearing behind the event horizon forever. There is a monster at the heart of our galaxy, and we are on a 230 million year leash around it, running at 500,000 miles per hour, and most people have never heard of it. Now surely this is the end. The biggest nesting doll has been opened. You are spinning, orbiting the Sun, orbiting the galaxy. 500,000 miles per hour. There cannot possibly be another layer. Let me just stop for a moment and appreciate what we have built so far. Start with a human sitting in a chair, feeling motionless. Zoom out, and the surface of the planet under that chair is whipping around at 1,000 miles an hour. Zoom out farther, and the whole planet is hurtling around a star at 67,000. Zoom out again, and the star and all its planets are careening around the galaxy at 500,000. At each step, the previous motion shrinks to insignificance. And at each step, the person in the chair feels exactly the same. Nothing, absolute calm, perfect stillness. If that does not give you a strange feeling in your stomach, you might not be paying attention. Because it means your senses are completely fundamentally useless for detecting the most basic fact about your existence, which is that you are in violent motion at every scale. Your nervous system evolved to detect tigers and falling rocks and changes in temperature. It did not evolve to detect the rotation of the galaxy, and so it lies to you. Effortlessly, constantly. It tells you that you are still, and you believe it, because why would you not? But there is another layer, and this is where the story goes from impressive to genuinely unsettling, because the galaxy itself is moving, and the way we found out is one of the great detective stories in all of science. To understand it, I need to tell you about the cosmic microwave background, and to tell you about that, I need to tell you about pigeon droppings. In 1964, two radio astronomers named Arno Penzias and Robert Wilson were working at Bell Laboratories in Holmdel, New Jersey. They had access to a large horn-shaped antenna that had been built a few years earlier for a satellite communication experiment called Project Echo. The idea of Project Echo was to bounce radio signals off a big shiny balloon in orbit, and you needed a very sensitive receiver on the ground to pick up the faint reflected signal. So Bell Labs built this enormous metal horn about 20 feet across sitting on a hilltop in New Jersey, and when the Project Echo work was done, Penzias and Wilson got their hands on it. They wanted to use it for radio astronomy, to map faint emissions from the galaxy, but the antenna was almost too good. It was so sensitive that it picked up everything, and that is where the trouble started. No matter what they did, no matter where they pointed the antenna, no matter what frequency they tuned to, there was a faint hiss of static. A low, steady, uniform noise that simply refused to go away. It was not loud, it was not dramatic, it was just there, constant, like a very soft, persistent whisper coming from every direction in the sky simultaneously. They were meticulous. They checked every cable, every connection, every amplifier, every solder joint. They rebuilt sections of the receiver. They accounted for thermal noise from the antenna structure itself. They corrected for radio interference from New York City, which was only about 40 miles away. They subtracted the known emissions from the Milky Way. Nothing explained it. The excess noise was about 3.5 degrees on their temperature scale, and they could not get rid of it. Then they found pigeons. 2 pigeons had set up house inside the big metal horn of the antenna, and had left behind a generous deposit of what Penzias later politely referred to as a white dielectric material. Now, any warm substance sitting inside your antenna horn is going to radiate a little bit of energy and look like extra noise. So they had a suspect. They trapped the pigeons, packed them in a box, mailed them to a Bell Labs facility about 40 miles away, and cleaned out the horn. The pigeons flew back, homing instinct. So they trapped them again, and this time the pigeons were dealt with more permanently. I will leave the details to your imagination. The droppings were carefully removed. The horn was clean. The noise was still there, unchanged. Same 3.5 degrees, same uniformity, same maddening persistence. Galaxies that should have been receding from us at a certain speed based on their distance were instead moving faster or slower than expected, depending on whether they lay in the direction of the flow or opposite to it. The pattern was unmistakable. Something was pulling. Something very big. Something hidden. They called it the Great Attractor, and for years it was one of the most frustrating mysteries in cosmology. Not because the concept was hard to grasp, but because we could not see the thing. The Great Attractor sits almost directly behind the thickest, dustiest part of the Milky Way's own disk. Astronomers call that region the zone of avoidance. Our own galaxy blocks the view. Imagine trying to study something important through a fogged-up window while someone is shining a flashlight in your eyes. You know it is there. You can feel its effects, but you cannot get a clean look. In 1987, a team led by Alan Dressler, a group that boldly named themselves the Seven Samurai, published a landmark analysis. They had measured the peculiar velocities of over 400 galaxies, the motions that remain after you subtract the normal expansion of the universe, and found a coherent flow. Everything was streaming toward one region. The gravitational pull implied something with the equivalent mass of tens of thousands of galaxies concentrated in that area. Over the following decade, astronomers attacked the zone of avoidance with every tool available. Infrared telescopes that could see through dust blocking visible light. X-ray observatories that detected the hot gas trapped in galaxy clusters. Radio dishes that picked up emissions invisible to the eye. Slowly, painstakingly, the picture emerged from behind the curtain. They found the Norma Cluster, a massive, rich cluster of galaxies sitting right in the heart of the Great Attractor region. They found filaments of galaxies, walls of them, long structures, stretching hundreds of millions of light years, like the ribs of some cosmic beast. But the real breakthrough came from a different approach entirely. Instead of trying to see what was there, some astronomers decided to map where everything was going. Think of it like studying an ocean current. You do not need to see the underwater ridge that deflects the current. You just need to track where the water flows, and from the flow pattern, you can deduce what is causing it. In 2014, Brent Tully and his collaborators did exactly this. They mapped the peculiar velocities of over 8,000 galaxies, the motions left over after you subtract the smooth expansion of the universe. They traced the flow lines. They identified which galaxies were streaming toward which gravitational basins. And what they found reshaped our understanding of our cosmic address. The Great Attractor was not a single mysterious object. It was not even a single cluster. It was a place, the bottom of a gravitational valley, the lowest point in a landscape of cosmic density, where the combined mass of thousands of galaxy clusters, filaments of matter, and unimaginable quantities of dark matter created a basin that everything nearby was slowly sliding into. They called this basin, this entire superstructure, the Laniakea supercluster. The name comes from Hawaiian. Lani means heaven. Akea means immense. Akea means immense. Akea contains roughly 100,000 galaxies. Although it spans about 500 million light years. To put that in perspective, light itself, the fastest thing in the universe, would take 500 million years to cross from one side to the other. The Milky Way is one tiny member, situated out toward the edge, falling inward toward the center. We are suburban residents in a cosmic metropolis so large that we did not even know it existed until a few decades ago. And behind the Great Attractor, even farther in the same general direction, about 650 million light-years distant, sits the Shapley supercluster, an even more massive concentration of galaxy clusters. Some astronomers think the Shapley supercluster adds its own gravitational tug on top of the Great Attractor's pull, like a second whirlpool downstream of the first, adding force to the current that is carrying us along. The dynamics get complicated. Multiple sources of gravity at different distances, pulling in slightly different directions. But the net result is clear. Our galaxy is moving fast in a specific direction, and has been for billions of years. We are falling, right now, toward a gravitational valley we can barely observe, dragged by the combined mass of 100,000 galaxies at over 1 million miles per hour. And in the grandest of ironies, we will likely never arrive. The expansion of the universe is pulling everything apart, even as gravity draws things together. That dark energy, whatever it is accelerating that expansion. That, over billions of years, expansion wins. Laniakea will dissolve, and the supercluster will drift apart. The galaxies that are today streaming toward the Great Attractor will eventually recede from each other, carried away by the stretching of space itself. But for now, for this particular era of cosmic history, we are caught in the current. The river is still flowing. We are still falling. Now I want to set the numbers aside and ask the question that really matters, the one that digs into the foundation of everything. What does it mean to be moving at 1.3 million miles per hour? Move relative to what? This question goes to the bedrock of physics, because ever since Einstein we have known that there is no preferred frame of reference, no absolute rest. The laws of physics work identically whether you are sitting still or coasting at 99% of the speed of light. No experiment you can do inside a sealed windowless room will reveal your absolute velocity. That was the revolution. That was what special relativity established. There is no cosmic speed limit sign that tells you what you are really doing. There is only what you are doing relative to something else. And yet, the cosmic microwave background seems to offer exactly what Einstein said could not exist. A universal speedometer, a frame of reference defined by the oldest light in the universe. If you adjust your velocity until the cosmic microwave background looks perfectly isotropic in every direction, no dipole, no warmer patch, no cooler patch, you are at rest in the cosmic microwave background frame, and every departure from that perfect uniformity tells you your speed and direction. Has the cosmic microwave background violated relativity? Has it given us the absolute rest frame that Einstein banished? No. And understanding why is important. Einstein's principle says the laws of physics cannot distinguish uniform motion from rest, and that remains true. If you are in a sealed laboratory moving at 600 kilometers per second relative to the cosmic microwave background, every experiment you perform, every electrical circuit, every gravitational measurement, every quantum interaction gives exactly the same result as it would at rest. No law of physics changes, no equation shifts. The physics could not care less. What the cosmic microwave background provides is not a law of nature rest frame. It is a stuff in this universe rest frame. It is a gas of photons left over from a specific event in the history of this particular cosmos, filling space. Measuring your velocity relative to that gas is like measuring your velocity relative to a river. The river is real. Your speed through it is real and measurable. But the river is not the laws of hydrodynamics. It is just water. It happens to be there. The laws of fluid mechanics work identically, regardless of whether the river exists, which direction it flows, or how fast it runs. You could have the exact same laws of water flow in a universe with no river at all. And here is the key distinction. If you could somehow remove the cosmic microwave background, erase it, imagine a universe that expanded and cooled in such a way that the photons all disappeared. The laws of physics would not change one bit. You would lose your convenient speedometer, but the speedometer was never part of the physics. It was part of the scenery. I think this is one of those places where people get tripped up because they confuse the universe with the laws of the universe. The universe is a specific place with specific stuff in it. The laws are the rules that stuff obeys. The cosmic microwave background is stuff. Interesting stuff. Ancient stuff. Universe-filling stuff. But stuff nonetheless. And measuring your motion against stuff is perfectly compatible with Einstein's principle that the laws of physics cannot tell you your absolute speed. You are not using the laws. You are using the scenery. The cosmic microwave background is the river. We can measure our motion through it, and the measurement is legitimate, useful, and astonishing. But that frame is contingent, accidental, a feature of this universe's specific history, not a requirement of any physical law. Einstein's principle is untouched. Relativity is intact. We simply have a very convenient, very old, very large landmark to measure ourselves against. And that brings me to the idea that I find most unsettling, more troubling in some ways than the velocity itself. Where did this speed come from? Why are we moving at 1.3 million miles per hour? What set us in motion? Imperfection. Remember those tiny fluctuations in the cosmic microwave background? 1 part in 100,000. Barely detectable. Those minuscule temperature ripples are the image of the early universe's slightly uneven density. In some places there was fractionally more matter, in others fractionally less. The differences were absurdly small. But gravity is patient. Over billions of years, it amplified them. Regions with a slight excess of matter pulled in more matter, which deepened their gravitational wells, which attracted still more. Those whisper-thin ripples became galaxies, clusters of galaxies. Superclusters, the filaments and voids and walls that form the vast cosmic web. The Great Attractor, the Laniakea supercluster, the Shapley supercluster, all of them exist because the early universe was not perfectly smooth. If the primordial cosmos had been exactly uniform, every point identical to every other point, then gravity would have had no handle to grip. No galaxies would form, no stars, no planets, no people, and no peculiar velocities either. Everything would sit perfectly, eternally still in the cosmic microwave background frame, and also perfectly dead. Your velocity is the signature of cosmic imperfection. 1.3 million miles per hour is the accumulated result of every gravitational tug in your neighborhood over 14 billion years. Every galaxy that formed nearby, every cluster that pulled on your cluster, every filament that channeled the flow of matter in your direction, it all adds up to one resultant vector, one speed, one heading. You are a gravitational fossil, not of bone and mineral, a fossil of force. The speed at which you sit here, feeling nothing, is a record of the entire structural history of the universe, encoded in your trajectory. Read it carefully and you learn about the conditions that existed at the moment of creation. I find that staggering. You are sipping coffee, perfectly comfortable, and your motion is a 14 billion year diary entry inscribed in the language of gravity. And we discovered all of it, because the temperature of the oldest light in the universe was a fraction of a degree warmer on one side of the sky, 0.1%. 2 radio engineers in New Jersey, scrubbing bird droppings out of an antenna, accidentally kicked off a chain of discoveries that revealed we are falling through the cosmos at a speed that dwarfs anything humans have ever built, toward a gravitational valley hidden behind the dust of our own galaxy, inside a superstructure 500 million light-years across, whose name translates to immense heaven. Physics is ridiculous sometimes. I mean that with the deepest admiration. So where does all of this leave you? You came in thinking you were sitting still. I have shown you that you are spinning, orbiting, spiraling, and plunging through the universe at a combined velocity that makes every rocket ever launched look like it is crawling. And the deepest joke of all is that none of these speeds are your true speed. There is no true speed. There is only speed relative to a choice of comparison. Choose the room, and you are stationary. Choose the sun, and you are doing 67,000. Choose the galactic center, and you are at 500,000. Choose the cosmic microwave background, and you are at 1.3 million. Each answer is completely correct. None is more fundamental than any other. Motion is relational. It does not belong to you the way your height belongs to you. It belongs to the gap between you and whatever you compare yourself to. And the sensation of perfect stillness, that calm, secure feeling of being at rest, is what happens when every object nearby shares your velocity. The chair, the walls, the air, the ground, all of them are co-conspirators, all moving at the same speed in the same direction, all keeping the secret so perfectly that you forget anything is happening at all. Think about what that means for the word here. When you say I am here, you mean a specific location. But that location is moving at 1.3 million miles per hour. In 5 seconds, here is shifted about 1,800 miles. By tomorrow, here will be roughly 31 million miles from where it is now. The chair you are sitting in is not in the same place it was when you sat down, not even approximately. The idea that you can go home and return to the same spot is a brilliant local approximation, good enough for everyday life, but cosmologically it is fiction. You are never in the same place twice. Every heartbeat happens in a region of the universe that your heart has never been before and will never visit again. The universe is not a stage on which things move. There is no fixed backdrop, no painted scenery, no grid nailed to the floor. There are only objects and fields and the relationships between them, all of them in motion, every last one. The question is never, am I moving? It is only ever moving compared to what? And right now, compared to the oldest light in the universe, the answer is 1.3 million miles per hour, into the dark. Towards something massive we cannot quite see, carried by a gravitational current that has been building for nearly 14 billion years. I want to leave you with one more thought. Something I have been turning over and over for a long time. We tend to think of the universe as a collection of objects. Stars, planets, galaxies, dust, gas, people, things with edges and shapes and positions. And we think of space as the container those things sit in, like a room, like a box. And then those things move through the box. But that picture is wrong. And not wrong in some technical, nitpicky way. Wrong in a deep way that changes how you should think about everything. And space is not a container. It is not a stage. There is no fixed background against which things move. The cosmic microwave background might seem like a background, but as I just explained, it is not. It is stuff. It is photons. It has its own properties that depend on the history of this particular universe. Take it away and the laws of physics still work. Put it back and they work the same. What we have is relationships. The Earth and the Sun have a relationship. 93 million miles, changing slightly over the year. The Sun and the galactic center have a relationship. 26,000 light years, roughly constant over human timescales. The galaxy and the cosmic microwave background have a relationship. 620 kilometers per second in a specific direction. Everything is defined in terms of everything else. There is no anchor, there is no nail in the wall that says, this point does not move. I think people find this disturbing because it takes away the ground. It takes away the notion that somewhere, at some level, there is a fixed foundation. A place that truly, absolutely does not move and against which all other motion can be measured. Humans crave that. We crave certainty. We want to know where we stand. And physics says, you stand in relation to other things. That is all standing has ever meant, and those other things stand in relation to still other things. And none of them at any level, at any scale, from atoms to superclusters, are truly still. The next time you sit down, drink your coffee, and feel like everything is calm and stable and perfectly still, I want you to remember what is actually happening. The spinning, the orbiting, the galactic carousel, the cosmic plunge, every atom in your body, every atom in the room, all participating in a silent, undetectable, magnificent rush through space. The only reason you survive it is that velocity by itself does nothing to you. Only changes in velocity can cause harm. And the universe, in its strange generosity, has arranged your particular trajectory to be so smooth that you cannot tell it is there. You have traveled about 31 million miles since you woke up this morning. You did not choose the direction. You could not have stopped it. You did not feel a single mile. But every one of them happened, and they will keep happening long after you and I are gone, long after the earth has been swallowed by the sun, long after the sun itself has faded to a cold white dwarf. The motion continues. It has been continuing since the beginning, and in some form it will continue until the end, when the last stars go out and the universe drifts into darkness, and the only things still moving are photons, endlessly redshifting, getting colder and colder, but never stopping, never ever standing still. If I asked you to choose one number, just one number, that best captures where you are in this universe and what the universe has been doing since the moment it began, what would you choose? I think 1.3 million miles per hour deserves serious consideration. Think about it. See if you agree.